Cool. All right. Thanks everyone for coming. This is September 10th, Athens office hours. So Scott, I know you asked me, there was a list of questions you had. I was wondering if it'd be cool to talk over those questions.
Yeah, go for it.
Cool. So I'm going to post them in the Zoom chat um, so everyone can see them, and then I'll just go through them verbally one by one. So does everyone see there's 4 questions in there in the chat right now? Cool. All right. So number 1, does proxy.golang.org use Athens? I don't think it does. And even and if they eventually open source their code, how does that affect Athens? It's not open source as far as I know. But keep in mind, I'm not on the Google team. So if it is somewhere and you find it, let me know. I would love to take a look at the code. But if it's not open source and it eventually is open sourced, how does that affect Athens? I think it would be awesome for Athens personally, because the more, so there's 2 things. One is more implementations of any proxy implementation, the more implementations of the download API, meaning any hosted thing or any open source proxy or a closed source proxy like Artifactory or whatever. I think the more that we have in the ecosystem, the better. And it's kind of like rising tide lifts all boats, if you will. So if there is another open source version of a proxy, I think it'd be really cool to set up a system where Athens and the new open source thing talk together and integrate that into the documentation and integrate that into the new things documentation to show how it can talk to Athens and kind of lift the profile of all of the proxies out there, and also encourage more people to run a proxy depending on their use case. So the short answer to how does it affect Athens is I think it would be really good for Athens. And I hope that Athens would be really good for it if and when it was open sourced. Does that kind of answer the question, Scott?
Yep.
Cool. Is there any other aspect that you wanted me to cover around like how does it affect Athens?
No, I was just curious because I heard about proxy.golang.org recently, and I was just wondering how it plays with Athens and friends. Yeah, that answers my question.
Cool. Okay. Yeah, I was told that it is not currently open source because it uses some internal, like internal stuff at Google. But right now, to me, the important thing that I really like is that it speaks the module API, so Athens can play nice with it, and other tools can play nice with it too. All right. So number 2, I'm going to try to say all this in one breath. There doesn't seem to be a way to troubleshoot Athens from Athens. Is that correct? For instance, if you wanted to troubleshoot logs, you'd just look at container or system logs, or if you were out of storage, you'd handle that manually by going to MongoDB or S3 or whatever option you have set up. So troubleshooting Athens from Athens, I think there's 2 aspects of that. Athens has tons of logs. They're not perfect, but hopefully over time they will get better. But right now it spits out a ton of diagnostic information. So kind of the first half of troubleshooting, I think you can do pretty well under most circumstances. And that would be just like figuring out what's wrong. But Athens won't help you do things like adding more storage. That would be up to you to go to like figure out how to get more disk space for your MongoDB instance or add more throughput to S3 or whatever. So did I get what you mean by troubleshooting? Was there more? Okay. So yeah, and if I get a lot of reports of like, I couldn't get this working. this was the log output. What did I do wrong? When I or any of the other maintainers out there see that, we pay close attention and try to figure out how can we increase the logs or make them clearer or add better documentation around that. Or ideally, how can we make it so that problem doesn't happen? Like if it's a configuration issue, that we could just make a non-issue by understanding the environment better or something like that. We do that too. So we really pay attention. So if you see something that's not working for you, mention it in Slack, or better yet, put in a GitHub issue. And we read those. We read every issue. So we really try to fix those particular issues first that make it harder for people to set up Athens some particular way that they want. So that was my shameless plug for please tell us if you have issues running Athens. Okay, so number 3, is there any work being done on the scalability of Athens? Maybe it's not at that stage yet, but things like huge number of packages stored or huge numbers of requests or handling no more storage space, etc. So right this very minute, there's actually no work being done on scalability. However, I do think that it is at that stage because the first aspect is because we assume most of the time that you will either be using cloud storage or you'll be using storage that is managed by someone in your organization that kind of knows that it's going to be a lot of storage. And that might be an incorrect assumption. And if it is, then we're not doing work right now to address that case where you're not using cloud storage or you're not using storage managed by someone else. So that's the storage side. We kind of assume that your storage will be scalable. So if you're using like disk storage, for example, we're assuming you're going to be using some attached block storage that can handle bursts and requests, and it can handle increased capacity. If you're using Redis storage, we assume that you're going to probably be using a production-ready Redis instance. And we're going to assume that you know how to increase the size of that instance. But Athens will not handle the case where there's no more storage. It'll just fail to write new packages in. So in that aspect, it doesn't have like a graceful failure mode to handle no more storage. And then on the other aspect, the huge number of requests aspect, Athens can handle running in a cluster. So what that means is you would run like whatever X number of Athens servers in a fleet. You would put a load balancer in front of them. And they all are the same. So there's no special Athens that is the manager of the other Athens. They're all equals. And they all get this thing called a single flight. And that's a concept that's built into Athens. But at its core, it's essentially a distributed lease, or it's a lease, but you can kind of think of it as a lock. So if you make a request to the load balancer, and there are 1,000 Athens behind the load balancer, your request will go to one of the Athens. It will look into storage and see that, oh, well, that module is not there at that version. That Athens will grab a lock to lock all 1,000 of the Athens from doing a fetch upstream for that module at that version. And then if another Athens gets the same request for that module at that version, it will wait for the first Athens to finish downloading it. And at that point, then both of those Athens can return to their respective clients to return that module. Excuse me. So in that sense, we have protected a huge fleet of Athens from doing a ton of unnecessary requests if they all get the same module request at the same time. And then we rely on a cloud provider or you to provide the routing in front of the huge fleet of Athens servers. So if you're running on AWS, we would just say, put an elastic load balancer in front of your fleet. If you're running in Kubernetes, we use the Kubernetes primitives to do the load balancing across all of your Athens pods. Same thing with like DigitalOcean or Azure or Google or whatever it may be. We assume that there is infrastructure ready for you already to do the routing and handle the large number of requests coming into Athens. And then we provide you with the mechanism within Athens to make sure that you're not doing all kinds of unnecessary work. So any other questions around the scalability aspect? Something I missed?
No, that was it.
Cool. And then the last one, what are the long-term plans for Athens? What I mean by this is that the docs say that Athens works well for CI/CD and within a single company, but I was wondering if there were more use cases or more goals that are being targeted for. So currently, Athens is targeted for, like you said, CI/CD. It's also targeted for internal use for developers to use. So that would be, let's say I am a CTO, I have a team of 1,000 developers that are working against maybe 5 different Go code bases. And I've got some private dependencies and I've got a bunch of public dependencies. The idea would be I can set up a single instance of Athens, maybe a cluster of a bunch of Athens, and then put the load balancer in front of them. And then my CI/CD system can use that Athens. And also all of my development team can use that Athens as well. And the Athens can be the central location to store all of my dependencies, public and private, that my entire organization, humans and CI/CD system, can use to access all of my dependencies whenever I need to get them. So those are the 2 primary goals. The last one that I'll mention is I personally like the use case of having people host public Athens. I do it personally. I think it's cool, and I like to sort of provide it as a proof of concept for people. And I wonder, I don't know if anyone else will pick that up, if other people want to host public Athens, because obviously it's paying for public infrastructure, and I totally get it. I don't want to pay for public infrastructure either. But it is a thing that's possible to do. And I like to think about how easy it would be to host a public Athens, because that kind of helps the use case of having a large organization internally to be able to easily host their own internal Athens. So those are, I would say, the 3 use cases. My goal is to make Athens as easy as possible to run, preferably to have one person run and maintain. And that's sort of what drives the whole core of Athens. And then Scott just added a last question. He says, correct me if I'm wrong, but I think in one of the office hours, you mentioned an interface that would abstract the storage options, i.e., e.g. Mongo or S3. So will a lot of the files in pkg config and pkg storage go away eventually? So you are right, yes. I mentioned an interface that would abstract the options away, but we would keep the existing ones in to maintain the backward compatibility. So those files in package config and package storage would stay, but there would be a new interface that would basically be some generic HTTP or gRPC protocol that you could configure Athens to run. And essentially, you would be pointing Athens over gRPC or HTTP to another server that you run. And that protocol that Athens speaks to the other server would basically be things like, I want to save a new module, I want to get a module. Basically, those are the 2 things. Maybe also I want to see if a module exists. And then whatever you implement in that other server would be basically the storage backend. So it's kind of like Athens has a bunch of built-in storage backends. And what we're thinking of adding is the ability to have Athens just call out to someone else and have that other person implement their own storage backend. So that's the distinction, is we're not going to replace all the existing storages. We're going to add another one that's basically just proxying down to some other storage. And that one is going to be a new thing that anyone can implement. And we'll probably, if we go to this route, we'll probably add all the new storage backends via that mechanism as other network servers rather than built directly into Athens. Does that make sense, Scott?
Yeah, thanks for the answers.
Cool. Yeah, and if there are follow-ups to this, other questions, comments, anything, feel free to ask now. And if you can't think of any now, or you think of something later, we can always do this. I can always answer questions here next week. I can answer questions on Slack too. So I'm not picky over either one. So if there are no other questions, I was thinking of continuing from last week with the pull request that I opened. That pull request had some code to implement a webhook that I had been thinking about doing for a while. So would people be cool with me sort of continuing down and showing the process of implementing the webhook and submitting the PR and all that stuff? Is anyone not up for that? All right, I'm going to do it. Let me open up all of my development tools real quick. Okay, I'm going to share my screen. All right. And I'm going to go back over to the pull request. I'm going to just remind myself what branch I was working on. It was a draft PR somewhere. Where are you? Here we go. Adding skeleton webhooks. So this one, just as a reminder, this is a follow-up. I'm actually trying to simplify a PR that I was trying to do before, which was to add a bunch of different webhooks that you could use to call Athens and trigger Athens to download a bunch of modules in the background. Then there was another set that was to be able to trigger Athens to register an alias to allow you to go and do a go get for, vanity module name, but really Athens would grab that module from a different source. So this PR is a simplification. It really just it gives you a webhook that lets you tell Athens to download a bunch of stuff in the background. But it doesn't do the aliasing thing at all. I decided to ditch that for now because there's a bunch more discussion that we need to do to figure out how aliasing will work. So this is under the proactive -webhook branch. So I have a bunch of aliases in my config. So you'll see me doing GS a lot, get status. This is also an alias for get status. And then GCO, just as a reminder, that's get checkout. So when you see me writing these short things, this is just specific to my environment. So I'm going to do a GCO, and then the branch is proactive-webhook. And I don't know what I did to my go.sum. So I'm going to roll that back. And I'm going to go back in here and update the branch. That's just going to make GitHub make this thing even with master. And then I can do a G pull, which is, before I run that, that's a git pull. That'll pull down the new changes. So Scott asked, if I have time, could I cover context? Yes. Let me actually look into context. Forgive the overload of words and the pun, but let me check out what context means in the context of this PR, because it actually is applicable here. So I'm going to open up VS Code. That's a shameless plug for my employer's development environment. I actually love it in real life, so it's not too shameless of a plug. And before we go in here, let's look at what the changes are in this pull request. So I obviously did not get super far. In the main, this is basically the main file, main.go pretty much defers all the real work to app.go. So it calls this add webhooks function, which is a new function. I have registered a single route /webhooks/bulk, and it has to be a post request. And then that is going to be handled by bulk async webhook handler. And that takes in a logger and a storage backend. And basically all I've gotten to so far is to decode the post body into this struct here. This struct uses a struct called webhook module here. So basically I'm expecting the post body to be a dictionary, a JSON object or dictionary with a single key, and that key should have a list of webhook modules in it. So yeah, I'm talking about context.context. And we've got some usage of it in here that I will get to in just a second. So going down here, I have some to-dos here. I'm going to skip over this to-do for today. This is how to return errors to the client. And I'm going to go into this to-do right now. And this is going to be the one that I'm roughly going to basically go fetch the module and store it into storage. There's going to be a ton more work to do than that, but I'm going to at least lay the sort of foundation for this. And this will involve doing some stuff with the context. So that's where we'll cover that. So we're going to go into webhooks.go. And heading down to this to-do, oh yeah, and Brent, really good description of it does with concurrency.go. There is also a really good screencast that Francesc did. It's called Just for Funk. And I think there's a 2-part series that's all about how to do context. So I'll dig that up and put that into into Slack unless someone else can find it before me. I would really highly recommend looking at that as well. So here we'll get a little bit of a taste for it. Let me just first get this out of the way. I am going to iterate through module to fetch.module versions. That is in here. So what we're doing is we're looping through each webhook module, so each one of these, and we're getting this thing called a module to fetch. Module to fetch is a thing called a webhook module. So that's this. Each webhook module has a module name and a list of module versions. So that's what we're doing in the inner for loop. We're looping through all the versions. So super roughly, we've got this storage.backend. We're basically looking to do this. We need to do a save. We need to pass in a context. That's where we're going to touch on that in a second. We need to pass in a module and a version. And then we need to pass in the actual module bytes, the bytes of the .mod file, IO reader of the actual module source code, and then the bytes for some the information metadata for that module. So we're just gonna super roughly hash this out. The module name is in module to fetch. The The module version is the thing we just iterated through. I'm just making up a variable name for that, for the .mod file. Same thing with the .zip file. And the same thing for the .info file. So, oh yeah, thank you, Banner. You found the link. That's awesome. So now the question is, where do we get the context? Where do we get the bytes, the zip, and the info? So first thing is the context. If we go back to app.go, we can see there's this function called add proxy routes. So add proxy routes is over here. And we've got this thing down here called the download protocol. The download protocol is right here. And this, well, let's first go to the download protocol.new. That is, where is that? Download.new. So this returns this new thing called a protocol. The protocol has this internal implementation. And going back to app.go, the add proxy routes function, download protocol, then we call .register handlers. So register handlers, it calls this r.handle a bunch of different times. So for example, it calls an r.handle to get the .mod, the go.mod file. So this is the path for that. If we head into the actual handler for module handler, you can see down here, there's a bunch of stuff going on. There's a bunch of stuff around logging and extracting stuff out of the path and information about the URL and all that stuff. But we have this dp.go mod call. You can see that it also takes in a context. And the important thing here is how are we going to get that context? Well, R is the HTTP request that came in here. And every request has this .context function on it. So in this case, the HTTP request, this type here, it has a .context function on it, which will return a context that is scoped to the current request. So as you might know, every single handler for every single HTTP request will be run in its own Go routine. And this context will be specific to each individual request in that individual Go routine. So the answer to our question about what context do we use, we're going to use r.context. And if I can find my way back to add webhooks, down here, we're going to call r.context. Okay, so that's the first question has been answered. So I'm going to make this a little easier for me to read. And before I get into the go mod bytes and zip and info, I'm going to just check the error here. I'm going to handle the error because we know save will return an error. So I'm going to check the error. Let me just save the error there. And then if error is not equal to nil, I'm going to put a to-do in here. And then I'll just return for now. Obviously, that's not really what I should do. But I'll figure out a better thing to do after I get the core stuff done. So how do I get the go.mod file and the zip file with the source code and the .info metadata file? For that, I'm going to go back into, not there, I'm going to go back into the download protocol. So the download protocol in the info file, this is going to show us a lot about what we should actually be doing to check to see if there is the module actually in storage, and then if it's not in storage, to figure out how we're supposed to actually download it. And that would be downloading it in order to get the module bytes and zip and info. So in here, we call our storage. So this is p.storage is the exact same thing as the storage backend that we're taking in here. So we're calling the storage backends .info, and the info is going to either give back the .info file. So that's the metadata info, which corresponds to this. And it's either going to return that in an array of bytes, a slice of bytes, or it's going to return an error. So the storage is going to check errors.isNotFound error. And that error, if this returns true, that error means that it's just not in storage. If it's not in storage, we call this process download function. And we'll see the same logic down below for the .mod file and for the actual .zip file, the source code. So the question then is, what does process download do? So process download goes and figures out a few things. So the first thing is it figures out what is the download mode. So the mode is calculated from this df. The df is a download file, and .match figures out what the method by which the module should be downloaded. So this is this thing that's really specific to the core module download API, not really specific to a webhook doing these downloads in the background. What it means is in the download file, you can say if a module is requested and it is not in storage, what should I do? So it's worth going into, just so you know. You can do one of 5 things. Athens can download it and then return it to the sender. Return to sender. Return it to the client immediately. That's what this is. It can download it in the background, and this is actually what we're going to be doing. It can redirect to somewhere that you've pre-configured. It can download the file in the background and immediately redirect in the foreground, or it can return a 404. So our deal is we want to do this. We want the webhook to return immediately with a success, but we want to go and do the download in the background. So I'm going to just literally copy this code over to the webhook, and then we're going to figure out what this actually means and how to actually do this thing with a stasher. So let's go over here. That's the easy win to start out with. The stasher is actually going to end up replacing this stuff that I have highlighted here. So let's go back to the protocol and trace where the stasher comes from. So the stasher is a stash.stasher. Going up into here, the protocol has the stasher in it. Going up to where the protocol is stored, the stasher comes from ops.stasher. So going back to where the download protocol.new is called, let's see if we can go find all references. That didn't work. There we go. So the download new is called here. This is again in the add proxy routes function. Yep. So heading over to the download.new, you can see it's passing in some options. The options they have the stasher in it. So let's go up to where the stasher is. Okay. So the stasher is created with stash.new. Okay. So in add proxy routes, we've got this stash.new. And we're going to need to get a hold of the stasher inside of our webhooks function. So first things first, let's take in the stasher. So that's the first thing. We can go now down here and we can just do a stasher.stash. For the context, we can do r.context, module to fetch, and module version. Okay. Module to fetch module name. Okay, so the deal with this thing is, and I kind of touched on this as part of the answer to that first question about, maybe it was the third one about dealing with clustered Athens. The whole deal with this is it figures out, this is that distributed lock. It figures out if someone else is already downloading, and if they are, then it's just going to wait until the download is finished, until the other Athens is finished downloading, and then it's going to just it's going to get the module.mod file, .info file, and the source. It's going to grab it out of storage and then return it. Or if no one is currently downloading the thing and it's missing, then it's going to go do the download, it's going to save it to storage, and then it's going to return it. So really, this is all we need. We're going to need to figure out how to pass the stasher in, and we'll get to that in a second. But let's go check out the stasher and sort of explore how this context is used. So the stasher is an interface. Let's go check out an implementation of the stasher. We're going to do the in-memory implementation because it's simplest. You don't have to know about external systems. So the in-memory implementation of the stasher is basically going to just be a bunch of Go routines that are protected by a lock. So if we go down here, our stash takes in our context. This is the interface implementation. And you can check out here, we call observe.startSpan. We pass in the context to that. And observe.startSpan returns another context, and then this thing called a span. So span, this thing is all about distributed tracing. But the way that it uses contexts is also a pattern for how contexts are used everywhere. So contexts are kind of organized in this tree. And in Athens, the context tree is also how we figure out sort of the stack of functions that we've called. And that stack of functions is really important to know because then we can report errors really well also when something goes wrong in Athens. So whoever called the stash function passes in their context, and then we immediately turn around and create a new context for ourselves. So it's kind of like we're adding a stack frame on top. That's basically what observe.startSpan is doing with the context. Then if we go down here, we start seeing we're using the context again. So we're calling another stasher internally. That's a little bit complicated, and that's out of scope for now. But this stasher internally, it has its own implementation of stash, and that's going to add another context, basically another stack frame, by doing another observe.startSpan. So the primary way we're using context inside of Athens really is this right here. So we're using contexts to basically figure out where we are in the call stack. And then you'll see in some other places in Athens, we're calling log.newLogger and we're passing in the context. And the reason that we're doing that is so the logger can output log messages knowing that stack information. So kind of it knows where we are doing a log based on the context. And the context holds that information about the stack and sort of the pointer to the stack where we are in the Athens code base. So that was a lot. We have 11 minutes left. So I wanted to pause and see if anyone has questions or comments, wants me to focus on a specific place. So if you have any of that, either put it in the chat, please, or just say it. Either one works for me. Did I cover enough about context?
Yeah, you did. I just think I have to research it more on my own.
Cool. Yeah, definitely watch that video. Also, contexts are not used anywhere near to their full potential in Athens. We didn't really need a lot of their power. one of the things that's really nice about them that Athens doesn't do is that they have timeouts. So like you can create a new context, and every context has this channel that anyone else can listen to, and the channel will be closed when it times out. So you can do stuff like, kind of hard to show in here. I'm gonna just do like some pseudocode basically. So I can do like func director, and then func worker, and both take into context. The director can do this. So you see how there's this context.withTimeout function. And that takes in a parent context. So we've got this parent relationship again. And then takes in a duration. So let's just say 1 second. So the thing that this returns is a function here, this done function, and that just releases internal resources. And then a new context that's a child of this context that you can pass to other functions, and this context will time out. So the way that you always do this is you defer, and then you can call your worker. I'm passing the worker a timeout context. Now the worker can figure out when to quit working by doing this. What this means is that when this context times out, the context will have a channel on it that gets closed. So ctx.done always returns a channel. The channel will either be open or closed. So if you wait on this channel, when the channel actually returns, when it's unblocked, you know that the context is canceled. So this is a common pattern to do this in a select, because otherwise you can do things like this. Right? So you can do the work otherwise, and you can wait on the channel. If you have a lot of repetitive work to do, you can do it inside of a for loop. So without having the code formatted that way, it'll look a little easier, a little simpler. So basically, this would be a worker that just keeps trying to do some work, and every time it just kind of keeps checking. It checks to see, are we done now? Okay, I'm going to keep doing work. Are we done now? Okay, I'm going to keep doing work. So in this situation, it's doing work forever until that 1 second is up. And when the 1 second is up, we're going to hit this case statement, and we're just going to bail out. So that's just like a tiny little bit about how the context timeout stuff works. And that is personally my favorite use of context, is to do that whole timeout thing with like the parent and child relationship. So yeah, if you have other questions, I'm totally happy to geek out about context some more. Just shout my way. So that webhook function that I have is actually almost done. So I'll push what I have to the pull request, and I may finish it up this week, but in all likelihood, I probably won't. I'll wait till next time. And we'll just like finish it up then, and we'll make sure the tests pass and all that good stuff. So we can see kind of like from end to end, how do we start? How do we get the test passing? And then we'll enter the phase of starting to get it reviewed. That'll be another interesting part. So yeah, with that, if anyone has other questions or comments or anything along those lines. Okay. So think about what you want to talk about next time. If you have any ideas or suggestions, let me know. Slack is the best way. You can DM me or at me on the Athens channel. Either of those works. And otherwise, I will see you next time. Next week, I will not be here. And the week after, we'll resume. So September, whatever is 14 days from now, 24th. Same time on September 24th, same place. And I'll tweet all that out and remind everyone as well. So thank you everyone for coming. I will see you in 2 weeks from today. See you, everybody.